Inshallah, in this class, we are going to see few basic sign formulas of quadratic equations. Now, the general form of a quadratic equation is ax square plus bx plus c equals to 0, where a is not equals to 0. Suppose we are having some equation x second degree equation. So, suppose this is called the quadratic equation. For example, this is a quadratic equation x square x constant. If we solve this one, we'll get the values of x as 2, 3. So the values of x are called the roots of the equation. Alpha and beta are the roots of the equation. Then we will have one formula: alpha plus beta is minus p by e, and alpha beta is c by e. Or we can say sum of the roots is minus b by e, and product of the roots is c by e. Product of the roots is c by e. Now next concept is see. If we have to find the quadratic equation when the roots we have the roots, quadratic equation with roots alpha and beta. Whenever we have the roots alpha and beta, the quadratic equation is given by x square minus alpha plus beta into x plus alpha beta equals to 0. Or we can write like this: x square minus sum of the roots into x plus product of the roots equals to 0. X square minus sum of the roots into x plus product of the roots equals to 0. Now condition for real roots is, whenever we have to take the real condition, we have to use b square minus 4ac greater or equals to 0. B square minus 4ac greater or equals to 0. The condition for equal roots is b square minus 4ac equals to 0. B square minus 4ac equals to 0. Now the roots of a quadratic equation is given by the formula x equals to minus b plus or minus under root of b square minus 4ac by 2a. Whenever we have to find the values of x of a quadratic equation, we have to use this formula, or can be obtained by factorization. The condition for quadratic equations, if we are having two equations, a1x square plus b1x and plus c1 equals to 0, and a2x square plus b2x plus c2 equals to 0, is condition for equal roots is common root. Condition for the equations to have a common root. To have a common root. Remember this: to have a common root means these two equations, if they have a common root, or the condition for common root is a1 b2 a1 b2 minus a2 b1 into b1 c2 minus b2 c1 equals to c1 a2 minus c2 a1 whole square. So this is the condition for common roots. Have a common root for the two equations. Now see the next concept. Quadratic inequations are ax square plus bx plus c greater or equals to 0, or ax square plus bx plus c greater than 0. In the same way, less or equals to 0, lesser than 0. For inequations, we are having these two formulas. If x minus alpha into x minus beta lesser or equals to 0, then the value of x lie between alpha and beta. Then the value of x, suppose this is number line, here we denote with minus infinity, here we denote with infinity, lies between alpha and beta means this value from alpha to beta. So we write x belongs to close bracket alpha comma beta. Suppose if we don't have equal symbol, just x minus alpha into x minus beta lesser than 0, then we use open bracket alpha and beta, means excluding alpha and beta, the values between alpha and beta. This means including x alpha and beta and the values between alpha and beta. So for lesser than 0, we see lie between alpha and beta. The formulas are these two. For greater or equals to 0, we say the value of x does not lie between alpha and beta. Does not lie between alpha and beta. So how to understand this? Suppose this is the number line. This is the number line. And suppose what we say just now, we have seen this is called, this is minus infinity, this plus infinity. Here suppose alpha beta does not lie means from here we should not have value between these two, or here does not lie between means either the values here or the values here. So how we can write? We can write from minus infinity to alpha union beta to infinity, minus infinity to alpha union beta to infinity. Suppose same equation, if we don't have the equation of equal, x minus alpha x minus beta just greater than 0, then we say minus infinity comma alpha open bracket union, because we don't have equal symbol, so we have to exclude this, or beta comma infinity. Okay, this we can write in one more way, that is R minus real numbers minus the values between alpha and beta. We can write this as like this also. R minus alpha comma beta. Now you see here ax square plus bx plus c is called quadratic expression. I'll just explain you here. See here. What is the difference? X square minus 5x plus c equals to 0. X square minus 5x plus c less than 0. And just f of x equals to x square minus 5x plus c. Here we are having equal to 0, therefore it is quadratic equation. If we are having less or greater, then we say quadratic inequation. And just we don't have equal or less or greater, just we are having f of x equals to x square minus 5x plus 6. This is called quadratic expression. Expression when you have equal here, equation, less or greater, inequation. So you must remember this one. Now watch here. Ax square plus bx plus c is called quadratic expression. It's called, we don't have equal to 0 now, therefore this is called quadratic expression. Quadratic expression. Now if, see here, watch carefully. If b square minus 4ac is less than 0 and a is greater than 0, a is greater than 0, then quadratic expression f of x is always positive, is positive for all real numbers. B square minus 4ac less than 0 and a greater than 0. B square minus 4ac less than 0 and a greater than 0, then f of x real is real for all values of x belongs to R. For all real numbers, f of x is positive. Suppose we are having b square minus 4ac less than 0 and a less than 0. B square minus 4ac less than 0 and a less than 0, then f of x is negative for all x belongs to R. Now next, see, we have to find, when we have to find the absolute maximum or minimum values, then you see here, for the same expression, if a is greater than 0, if a is greater than 0, then f of x has absolute minimum value at x equals to minus b by 2. For greater than 0, we have absolute minimum. For less than 0, we have absolute maximum. If f of a greater than 0, sorry, if a greater than 0, then f of x has absolute minimum value at x equals to minus b by 2. And if a less than 0, then f of x has absolute maximum value. The expression will have absolute maximum value at x equals to minus b by. Both values will be same, only depends upon a. If a greater than 0, minimum value. If a less than 0, maximum value. Now what will be the minimum value, maximum value? Same formulas. 4ac minus b square by 4a. 4ac minus b square by 4a. Only depends upon a. If a greater than 0, we say that the values are minimum value. And minimum value at x equals to minus b by 2a. And the minimum value is 4ac minus b square by 4a. If a less than 0, maximum value at x equals to minus b by 2a. And the maximum value is 4ac minus b square by 4a. Now you see the last concept. If the roots of the equation ax square plus bx plus c equals to 0 are complex or we say imaginary, that is, if b square minus 4ac less than 0, that is, if the roots are complex, then both ax square plus bx plus c and a will have the same sign. Ax square plus bx plus c and a will have the same sign. So these are the few concepts and basics of the quadratic expressions. Inshallah, we are going to continue in the next class.